Warm up. Find all the solutions to the equation in the interval from 0 to 2 pi. So secant theta is 1 over cosine theta, which is equal to, just leave this 2 alone. I'm going to flip it. Cosine theta equals 1/2. It's positive cosine, this is x. And so it's got to be here. Cosine theta x. And then this hypotenuse 2. So if this is 1, then that makes this root 3. So this is going to be 60 root 3. Root 3. Yeah, so this is going to be root 3. 60 degrees is pi by 3. So it would be pi by 3 or negative pi by 3. Okay, better. Double angle formulas. Ooh, I did not even practice. Oh my God. All right, let's go. Lesson 7H double angle formulas. I haven't even looked at this at all today. Uh-oh, how are we gonna do this? All right. What is sine 2 theta equal to? How can we figure this out? Would you agree that this is true? Would you agree that 2x is the same as x plus x? Would you agree on that statement, yes or no? X plus x is 2x, yes? So if you agree on this statement that 2x is x plus x, then I'm going to say that sine theta is what in terms of sine what? What should, if you understand what I said here about here, what should I write down right here? Theta plus theta? Let's go. Okay, so sine 2 theta is sine theta plus theta. But I do remember we did that one long proof that was very tedious to do. It was some formula saying that sine alpha plus beta. Do you remember that? How did it go? It was something like sine what? Sine alpha cosine what? Beta plus cosine alpha sine beta. Okay, that is what we proved. We already know that that should be true, and we don't want to do this proof again. So you can just kind of treat this is alpha and this theta is beta, and it's the same thing, so whatever. Okay, so then we're gonna do this. Sine theta sine theta times cosine theta plus cosine theta sine theta You tell me what the answer to that is. 2 cosine theta sine theta, yes? This is this, and you got 2 of the same thing again. So then, this sine 2 theta turns out to be 2 sine theta cosine theta. There's our first double angle identity. Sine 2 theta is 2 sine theta cosine theta. Okay. Well, there's the proof, whatever, but that's what it is. Sine 2 theta is 2 sine theta cosine theta. Okay. Let's go now to the cosine 2 theta is equal to what? So we got that one already. Cosine 2 theta. That one only has one. This one is going to be the same as saying cosine what? Just the same as we did the other one. Cosine what? Theta plus theta. Theta plus theta. So we got cosine 2 theta is cosine theta plus theta. But then let's remember what was that identity that we did not prove. That it says something like cosine alpha plus beta. Cosine alpha plus beta. What was it? Cos. I know it was cos. 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 Then what? Is the opposite of plus is going to be what? It was minus what? Sine, no? Cos, sine alpha beta. Cos, okay. All right. Let's plug it into this thing here. Okay, so this is this. So we go here, and so this is going to be cos theta times cos theta minus sine theta. What's cosine theta times cosine theta? Cosine what? Square theta. It's cosine times cosine is cosine square theta. Minus what? Sine square theta. That is one identity. Another one. Cosine 2 theta is equal to cosine square theta minus sine square theta. Okay. There's some other ones that come out of this. There's this one has a total of 3 of them. 3 of them. Well, where do the other 2 come from? Where do the other 2 come from? Okay. So, what did we say about the most basic trig identity that is very important? Is sine squared theta plus cosine squared theta is equal to what? 1. This is as basic, important trig identity. What I'm going to do is, I'm going to substitute in for cosine squared theta something that will come from here. So cosine squared theta, if I can move this over to the other side, I'm going to get minus sine squared theta. So I got cosine squared theta would be equal to this 1 minus sine squared theta. Okay, so cosine squared theta is equal to this thing. I'm going to go ahead and substitute into that. So I'm going to get 1 minus sine squared theta minus that sine squared theta is already there. So what is the answer to this? It's going to be what? 1 minus what? What's negative x and negative x? Negative 2x. Negative 2x. So this is going to be negative 2 what? Negative 2 sine squared theta. So here's another identity. That cosine 2 theta is 1 minus cosine 2 theta is 1 minus 2 sine squared theta. Well, we're going to go back to this here again, but instead of solving for cosine, we're going to solve for sine. So let's go back over here, and then instead of this, let's solve for sine. Sine squared theta, this is sine squared theta. So I'm going to solve for sine. I'm going to solve for this. So this is going to be negative cosine squared theta. So sine squared theta, I'll write it down. Sine squared theta is equal to 1 minus cosine squared theta. So this sine squared theta is that. So we're going to go here and plug it in. So we got cosine squared theta. And we got to put it in parentheses. I'm going back to this one right here. Sine squared theta is this. 1 minus cosine squared theta. Distribute this negative 1. So we're going to have cosine squared theta minus 1 plus cosine squared theta. Which is going to be cosine squared theta, and another cosine squared theta is going to be what? 2 cosine squared theta minus 1. There it is. There's all of them. So you need to know these ones. 1, 2, and 3 for cosine 2 theta. Yeah, let's go. All right, there's the summary of everything. I proved it to you that these come out of not just made up. These are actually true statements that are this one has 1 and this one has 3 identities. Those are the ones right there. And now we're gonna use these identities to solve some of these that have a 2 and 2 theta, to be able to solve it without a calculator or anything. So we're going to use a double angle identity to find the exact value of the expression or the equation of each equation. This is not an expression of each equation. Okay. We're going to solve for cosine 2 theta. Now here's the question. Which one do you... Definitely I don't think you want to use this one. We're looking at cosine 2 theta. We're looking at the second one. I don't think you want to use this one. Maybe you want to use this one or this one. One of these you could use. I will use... Oh, I prefer sine, but for this particular one, I'm going to use cosine. So 2 cosine squared theta minus 1 is equal to cosine 2 theta. Cosine 2 theta, I'm going to plug in that over there. 2 cosine squared theta minus 1 minus 1 equal to 0. All right, so we got what? 2 cosine squared theta minus 1 and minus 1? Minus 2 equal to 0. And it just becomes what we just did before. What's today? On a Monday? Yeah, Monday, because it's Wednesday. We did, it goes back to those solving equation ones. Add 2 to the other side. So you're just using these identities to help you get to that point. Divided by 2, divided by 2. Cosine squared theta equals 1. So we got cosine squared theta equal 1. Okay, so now what do we do next here? I'm at this step. Huh? Square root it. Square root it. So we're gonna get cosine theta equals plus or minus 1. You gotta have that in your head by now, the unit circle. What's the answer for the... Who's answered? What are the answers? What angle gives you a... What are the angles? Did somebody say what? Is it pi? Yes? And would it be 0 too? Use the double and then to find exactly... this is messed up. It should say from including from 0 to 2 pi. Not including 2 pi. So use the double angle and then to find the exact value of each equation on the interval. On the interval 0 to 2 pi. So on 1 revolution. So it is going to be pi. Well, isn't it 0 though? First, let's go with 0, no? It's 1, yes? 0 and what? Pi? Yes or no? Do I need to do a little draw circle? Let's see. Let's see. Did we? Okay, 0 to pi. Cosine here at 0 is 1, and then at pi is negative 1. All right, that's it. That's the idea of this whole thing, and it's just knowing how to choose which one and which one makes it easier and which one doesn't. Most than likely you don't want to use this one. Maybe see, you want to use either the second or third one. Right now, Brianna not here. Becky here. Brittany not here. Hayden is here. Back? All right. Oh, you can go to break out the wall. Break Becky. Okay. Which one do you guys want to use? Definitely don't say 1. Which one you want to change it up? You guys want to change it up and do 2? Yes or no? Let's use cosine 2 theta. Cosine 2 theta, let's use this. Just to change it up a little bit. Maybe not. Maybe not. Why not? Why not? Because, why not? Because this has cosine and this other side has cosine. Stick to the third one. If this one would have been 5 sine theta, you would have used this one. Yes. So yeah, really, you don't want to be using just any random one. All right, so let's use the third one. It goes back to, again, if you can just understand that x is cosine theta. Let's just remember these things. X is cosine theta, y is sine theta. And so if you have some x squared, you got some x squared, is because you got a cosine squared. If you have some y squared, it's because you got some sine squared. You just got to be able to change these things like this. So here you're looking at, forgot the theta. So you're looking at 2x squared minus 1 equal 5x plus 2. So it's a quadratic. So you want to move things around. This is 2x squared. You remember, if you, I'll do it here on the side. 2x squared, really what you got? 2x squared minus 1 is equal to 5x plus 2. That's really what you're looking at, in other words. Okay, so you know how you would solve this. If you want to look at this, how to do this one, you would just move it because it's a quadratic. Minus 5x, set equal to 0. That's kind of like what we did last semester. So that's what we're gonna do here, and do the x. So here, this one's gonna turn out to be, it's gonna be that, where x is cosine. So let's go with 2 cosine squared theta minus 5 cosine x, cosine theta, minus 3 equal to 0. You could do the x there, or you could do the x here. It doesn't matter. What was at the bottom? If you're gonna follow my x method that is frowned upon at the other schools, middle number to the bottom. What was on top? Negative 6. Numbers are what? Multiply it to equal that, add up to this. What is it? Negative 6 and 1. And then I already said it. I was going to ask. Then don't forget, if you're going to use my method, divided by 2. Divided by 2, divided by 2. So negative 6 divided by 2, it was negative 6 divided by 2 is negative 3. Circle that. Circle this. And we go directly to what? X equals, which x is cosine. So we're going to say that cosine theta is equal to what? Did you say negative 3? Positive 3? Positive 3. Okay, and then cosine theta is going to equal to what? Negative 1/2. On the homework, in one of those, I think it was the inverse function one homework, that you were supposed to use a calculator for this. When it said cosine theta equal to 3 or cosine theta equal to 5, what are you getting when it says that? Did it say error? Yes or no? Look, this is going to be, this makes no sense. Why? Because for any cosine or sine function, a cosine function goes like this. What's the highest it goes? What's the highest a cosine function goes? The highest it goes 1. What's the lowest it goes? So the answers are between 1 and negative 1 and 1. So if it's past b, it's inside there. When it says it's 3, it just makes no sense. Throw that away. So now Where are the solutions for cosine negative 1/2? Cosine negative 1/2, right here, because cosine is negative. This is negative. This is 2. This is 2. This is root 3. So it's root 3. You go back over here. Root 3. This is root 3. If this is root 3, because this is pi by 3. If that is pi by 3, then this is what? 2 pi by 3? And this is going to be what? Huh? 4 pi by 3? Okay, last problem for today. Here's the last problem for today. Use one of these double angle formulas to sketch a rough graph. Use double angle to sketch a graph of the following equation. Y equals 8. What are you going to plug in for sine squared theta? You got too many choices? Do you have a lot of choices here? Well, no. What am I doing? No, that's not it. How the heck is this gonna be that or that? Oh, got this wrong. Which one are we looking at? What are we looking at? That one. Sine squared theta. Sine squared theta. Okay, so we're gonna go. This is equal to this. Yep. Let's go. So it's gonna be cosine 2 theta. How are we going to do this? Look, basically, let me solve for sine squared theta. Let me solve for sine squared theta here. Let me solve for sine squared theta. Let's solve for stuff. So this is going to be what? -1, -1, cancel this. Cosine 2 theta -1 equals -2 sine squared theta. I want sine squared theta by itself. I want sine squared theta by itself divided by -2. Divide this by -2. Cancel. Now I got my sine squared theta by itself. There's a 1 here, so it'll be -1/2 for this part. -1/2 here, and this is positive. A negative times divided by negative, positive 1/2. But forgot to put my cosine theta here. 2 theta. Positive 1/2. There it is. So this is this. -1/2 cos 2 theta plus 1/2. Close it. -2. distribute. So y is going to equal 2. Half of 8 is negative 4. It's a negative. Cos 2 theta. This is going to be 4 minus 2 here. So it's going to be y equals negative 4 cos 2 theta plus 2. And I hope you remember how to do this from chapter 6. Cos. What's the amplitude? Let me see. Who's like, that was so long ago. How do you expect me to remember that kind of stuff? The amplitude is 4. How many birds are there? 2 birds? Yeah, see? That's learning when you just remember. And what's the midline? 2. So now we're going to make a graph. This graphing from 0 to 2 pi. Well. It was shifted up too. That's messed up graph over here. I needed to make it. It's gonna be because it's up. Let me make it more lower so I can be able to graph it here. 0, pi by 2, pi, 3 pi by 2, 2 pi. Shift it up 2. So here's the midline. So from 0, and it's upside down also, because it's negative. So the bird is not where it's like this, but where it's like this, like a Snapchat little thing here. So what? Amplitude is 4? We said it's 4, no? What does amplitude mean? From the what? From the middle to the highest, or from middle to the lowest, no? So it's gonna go what? 1, 2, 3, 4, right here. Because it's a 4, but the thing is upside down, no? Like that, and then another one, no? 2 of them. 2 of them within from 0 to 2 pi. So from you better see a Snapchat thing, ghost, like this, from here, like this. And then another one here, no? Whatever, something like that, yes. It goes on forever like that. That is it for today. Boom, 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 bust. What? Where's the graph? I thought we're done. No more. Let's do one last one. I don't know. Let's one more. Find the exact value of tangent 120 by using identities. The way we started trigonometry was by doing that tangent 120. I'm just giving you a review of something else that we did. 120, we got to get to 120. This is 90, so I got to go another 30. So I'm right here. So this is, and then you get the reference triangle there. So this is 60, radical 3, 31, that's negative, and 2. So the answer should be tangent is opposite over adjacent. So it's going to be negative root 3. This is what we're looking for. We just want to make sure that it is negative root 3. The answer. Which one do we want to use? Find the exact value of that by using one of the identities. Yeah. I like, no I don't. Okay, so we're going to do sine, well, tangent theta. Well, theta is what? Tangent of 120? Tangent 120 is the same as saying what? Sine 120 over cosine 120. So 2 theta, well, we're gonna do sine of what? Sine of what? Plus what? What plus what? This plus this, which are the same, equal 120. What is that? So for the top, now we got sine 2 theta, which is that right there, is equal to 2 times sine 60 cosine 60. Let's see, which one do you want to use here now for cosine this one? Want to use this one? You want to use this one or this one? Hey, just to make it fun, let's do this one that is being neglected. Let's use this one. Let's use that one. So then this is going to be what? Cosine 60 squared minus sine 60 squared $60 is what we're looking at. 60 degrees, 60 radical 3, 2, 31. That's what we're looking at. Let's go over here. Let's put the numbers. 2. What is sine of 60? You're standing right here. 60. What's sine of 60? And man, if it's not the whole class, please. What's sine of 60? Root 3 over 2. Yes or no? Yes? I'm telling you right now. No, I'm telling you that I told you already before that by now, if this is not simple, because we've done it so much, it's just like sine of 60 is going to be opposite over hypotenuse root 3 over 2. And what is cosine 60? This is cosine 60 is what? We're looking at this, please. What's cosine 60? Huh? 1/2. What's cosine 60? What is it? 1/2, is it? And what are we going to do with the 1/2? We're going to square it minus what? Sine 60. What's sine 60? Root 3 over 2. Root 3 over 2. Square it. I'm working backwards here. Let's see here. Erase. Square root. Okay. So on top is going to be what? What is this? Root 3 times 1 is root 3 over what? 4? Yes? Root 3 over 4. And this is going to be what? 1/4? Yeah? And this one's going to be what? Minus what? 3 over what? 3 over 4? Huh? Yes or no? 3 over 4? I'm going everywhere. I'm just... So now, we got square root of 3 over 4 divided by, what's a 1/4 minus 3/4? What is 1/4 minus 3/4? Negative 2/4? What can we do there? And what's the answer? Negative root 3 over 2. Wasn't that the answer? We had done, this is just like elaborate, but the answer was that. And it always all works out. Is that it, please? Is that it? Did I mess up on me on this one? It's tangent.
I think you forgot the 2.
No, tangent can't be. Tangent is negative root 3. I made a mistake. Can I go back? Can I go back? You know that tangent is 120. Were you guys? That's why I said people confused. Let's go back. 90. How much more do I have to go? 30. This is makes it 60. 60, opposite 60. Root 3. 90. 2. 30. 1. Tangent is what? What is tangent? Tangent of an angle, what is it? It's O over what? It's getting hot in here. O over A. And O is what? Opposite is what? Root 3 over, and this is negative. This is correct. And the other one I messed up?
I think you see that first equation at the bottom? Where it says 2 times root 3 over 2 times 1/2? I think you forgot the 2 in there.
When I was doing it?
Yeah.
Oh, thank you for saying you forgot. So you got it wrong. Some kids love it, like when I mess up. Where? Which one? What did it say? Where?
The red one to the yellow, you forgot the 2.
From here to here?
Yeah.
And if I did forget that too, then we go back over here, and this everything's okay. So we got 2 root 3, let's leave it like that, over 4 over, what is this? Negative what? Negative 3 over, negative 2? Is it negative 2? Over what? Over 4. Cancel, cancel. So I'm going to get 2 over root 3 over negative 2. Yeah. See, sometimes when I make, it's correct now. So we're done. Yeah, sometimes it's good to make mistakes because then we started really thinking about what the heck is going on here. Open and whiteboard, save as. What's that? 7H. That is it. We're done with this chapter or unit now. It didn't stop.